Today on this episode of The Crossover, we will be discussing the free energy principle with renowned neuroscientist at the University College London, Dr. Thomas Parr. Learn about the most all-encompassing idea since the theory of natural selection and how it impacts each and every one of us every single day. Much more on this episode of The Crossover. Good afternoon, everyone. Going to be talking with Dr. Thomas Parr today from England, one of the thought leaders on the free energy principle. Hey, Thomas, how you doing?
Good, thank you. How are you?
I'm all right. Listen, thanks for joining us. Very excited to talk to you today. I've been doing a lot of reading about this free energy principle, and I can't say it's easy to understand, but I feel like I'm finally getting a grasp, and so look forward to speaking to an expert on it. I'm going to do a brief introduction just while everyone's logging on. We have the pleasure of speaking with Dr. Thomas Parr, who is a recognized neuroscientist and faculty at the University College London. Thomas obtained his MD and PhD from the University College in the theoretical neurobiology group led by Professor Karl Friston at the Center for Human Neuroimaging. His research interests include active inference, computational neuropsychology, and the oculomotor system. And like I said, we're here today to discuss the free energy principle, which I've been doing my reading on. I feel like I have some basic knowledge and look forward to learning more. So thanks so much for joining us.
Well, thank you for having me.
So let's just start with basics, Thomas, because I'm pretty sure that most people that are listening may not have an idea of what the free energy principle is. And you could talk for hours, I'm sure, about it, but in 2 or 3 minutes, is it possible for you to just summarize what is the free energy principle?
Yes, I think so. And so the basic idea of the free energy principle is that it's about the fit between us and our environments. And the idea is simply that we try and ensure the best fit that we can. And that may be through changing our environment so that it fits us better, or it may be through learning about the environment, changing our beliefs, changing our inferences about the environment so that we fit it better. And free energy is just a way of measuring that fit. And so the idea is that because we can change that fit either by changing ourselves or by changing the environment, we have a sort of dual imperative to optimize this free energy. And that dual imperative includes both action and perception. So the free energy principle really provides a way of unifying the neuroscience of action and the neuroscience of perceptual inference.
Would you say that the free energy principle essentially explains how our brain interprets the world around us?
Yes, yes, I would. But I think there's a caveat I'll add to that. So I think it gives us a good framework, a good principle to work from. But what it doesn't do on its own is tell us about a specific cognitive process or how my brain works in a particular setting. And so the idea, to sort of come back to that idea of fit in a bit more detail, really, essentially we assume that our brains have a model of how the world around us is evolving. We're constantly trying to predict what's coming next. And so the fit really is in the sense of how well our model fits the world around us. Now, the free energy principle will tell us how we might optimize our model, but it doesn't tell us necessarily what our model is. So the interesting neuroscience, the bits where you then try and explain how the brain works in a particular setting are really trying to work out, well, what is our internal model? What does it look like? What sort of predictions do we make? And once you have that model, you can apply the free energy principle to it, but you really need both parts in order to be able to come up with an explanation.
So how does the free energy principle work its way into the way that we make decisions, right? Because human beings interpret the world differently. We make different decisions. Some of us have good judgment, bad judgment. Some days we have good judgment, bad judgment. How do you feel that the free energy principle relates to the way that our brain makes decisions on a daily basis?
So there are a couple of key things to pull out there of what you said. So first is thinking about what decisions are, and then the other part is thinking about how decisions differ between different people, and why some people make what we think are good decisions and some people make what we might think are poor decisions. I would say that a decision is essentially a selection between alternative ways the world could play out, and particular alternative ways that I could influence how the world plays out. And that process is itself formally analogous to the idea of selecting between models of the world. But the big difference here is that I'm now not selecting based upon, data I've got coming in, trying to come up with the best explanation for what I've got at the moment. I'm now saying, anticipating what I'm going to get in the future, what sensations I'm going to receive, and my different preferences for those. I can now select between these different views of the world, or different views of the way the world might play out, based upon what I expect to happen under each of those different plans. Now, the other part of the question really is about, well, why do some people make good decisions and some people make bad decisions? And it might seem like a slightly strange thing if you take a principle that says everything is essentially behaving optimally. It's optimizing some value function or some free energy, because lots of people will say, well, lots of decisions appear to be suboptimal. One of the things the free energy principle does is it actually turns that on its head a bit and says, no, actually, we're going to say that all decisions are optimal, but the model you're using to make those decisions may not be. So each person may have a different set of prior beliefs about how the world is, and those prior beliefs will influence which option leads to the lowest free energy. So it's a sense of optimal inference, but potentially under a suboptimal model.
Interesting. I mean, the other thing that I think is key for anyone trying to understand the free energy principle is the idea of the Bayesian, well, it's the Bayesian idea of the brain as an inference engine. And that took me a while to understand. What exactly is an inference engine, and how does the brain play into that?
Well, I suppose the key way of looking at it is that we don't have direct access to things in the world around us. We get sensory impressions through what's projected onto our retina, but we're not actually seeing directly what's out there in the world. So our brains have to reconstruct what's caused the impressions on our retina, the vibrations in our cochlea, touch on our skin, all of these sorts of things, to actually then interpret that in terms of its causes and experience the world around us. We need to perform inference. And there's often no one answer to those things. There are different ways you can interpret the same stimuli. If you imagine sort of a shadow cast on the ground, depending upon which direction the sun's coming in, you could have lots of different things that might cause that same shadow. So inference is the process of going from that to your explanation of what's caused it, and it's something that the brain has to do with everything we receive, because we never have direct access to the things we're really interested in.
The term free energy might be a little bit misleading, right? People think of energy in different ways. How did you guys, or how was the term free energy decided upon, and why do all living things try to minimize free energy?
So the concept of free energy comes back to physics, and originally arose in looking at things like thermodynamic systems. And the way I tend to think about it is just that very high energy systems are generally quite improbable. They tend to be configurations of things that are quite difficult to maintain, whereas you're much more likely to find things in sort of low energy states, or more diffuse and spread out. So the idea, I think, there links together the idea of probability and energy, and there's a very tight link between the two of those things in physics and through Boltzmann and people like that. We're really talking much more in a probabilistic sense, but the same language and the same concepts transport across from those regions of physics.
That makes sense, and I think the other kind of unifying statement that I was reading over and over again, and I thought that this made it more easy to understand, was that every organism is trying to minimize how surprising the experiences they undergo are. I mean, do you agree with that? Basically, that our brains are going through the world, and it's an inference engine. It's trying to understand the world around us. And we are always trying to minimize the amount of surprise that we undergo. Is that correct?
That's exactly right, yes. And I tend to think of this in terms of something that most biologists will be familiar with, the idea of homeostasis. And for those who aren't familiar with that, that's the idea that to continue surviving, we need our physiological parameters, our blood pressure, our temperature, those sorts of things to all be within some fairly narrow, well-defined ranges. Another way of looking at that is just to say that if we were to, assuming that we are continuing to exist and survive and be healthy, it would be quite surprising to find those parameters outside those ranges. So it'd be quite surprising for you or I to sort of have a temperature of 0, for instance. So the idea that we're trying to minimize surprise is really just saying we're trying to keep things within the sort of range that is plausible, conditioned upon our continued survival. And in a sense, that's just tautologically true. There's, if we were in more surprising ranges, then we would stop existing. One of the classic examples that's often given in the free energy literature is the idea that a fish being out of water would find its environment very surprising, and a fish that's out of water also would not survive very long. So you can sort of see how the two relate to one another, that survival and the minimization of surprise sort of inherently link to one another.
And I think it's also, you just made kind of that analogy. I think it's important for everyone to understand that this is not just humans. This is every living being on the planet, correct? I mean, this is one of the characteristics. This is one of the characteristics of being alive, correct?
It is. Yes. You could potentially broaden the argument in terms of surprise as well to various other sorts of self-organizing systems, and even to artificial systems as well. Anything that persists in some form for a sufficient length of time, that statement of persistence is just saying that there's a plausible range of states that you expect it to be in, and it would be surprising to find it outside of that range.
Now, when was the free energy principle first proposed?
So it has quite a long precedence, and I suppose it's difficult to pick a specific time for that. So you could go back to certainly the 1900s and look at people like Hermann von Helmholtz, who spoke about free energy in other contexts, but also spoke about the idea of unconscious inference and put together those ideas. Many would go back much further than that. I think in its modern form, we're probably talking sort of the early 2000s when Karl Friston started formulating it explicitly in terms of the minimization or optimization of the free energy functional, and the idea that we are using that to optimize both our perception in the Helmholtzian sense, but also the way we act upon the world, and unifying those two branches of neuroscience.
Now, just so people have a context, that this principle has even been called the theory of everything, just so people have an idea of how important this theory could be. Do you agree with that statement, that the free energy principle can be summarized as the theory of everything?
I think it to some extent that phrase was used a little bit tongue-in-cheek, and there is an element to which that's true. What I mean by saying tongue-in-cheek is that the idea when that phrase was put out for the free energy principle was that it deals with everything, sort of separating out those two words, and questions what is a thing. And the idea is that to be able to think of something as being a thing and separable from its environment and not just part of some homogeneous mass, it needs to have some sort of boundaries that mediate its interaction with the world around it. And that comes back to what we were talking about much earlier on, about the idea of an inference engine, the idea that we only get a sort of limited interaction with the world via our sensory receptors and via our muscles. We don't have a direct influence, and if we did, we would be indistinguishable from the world around us. So the argument is that sort of interface and the dynamics of that interface are to some extent consistent across anything that you can separate from its environment and distinguish as a thing. So in that sense, yes, I think it does deal with everything. On the other hand, I think the idea of minimizing free energy and the idea of perceptual inference is probably less relevant for many sorts of things compared to things like us.
Now, the free energy principle definitely has naysayers, as every theory does. What are the neuroscientists and the philosophers who do not believe in the free energy principle? What do they say?
Well, I mean, to some extent, it almost be better to ask them. There are a number of criticisms that are sometimes levelled at the free energy principle. So one of them is that people find it's quite challenging to get to grips with, and I think that's a perfectly reasonable criticism.
I agree.
Want to make it as accessible as possible, and in a way, it's a shame, because the idea is that trying to summarize things in terms of a first principles account, where there's one thing that you need to get to grips with, actually simplifies things in many ways. But one of the difficulties is that because it is sort of mathematics is not part of standard biological training or clinical training, and the number of different fields that link together, it's very interdisciplinary, sits at the interface between engineering and physics and computer science and all of these different areas. So people often find it quite difficult to get together all the resources and all the training to be able to approach that. Another criticism that's sometimes levelled is one of falsifiability. And people have the idea that if you're putting forward a principle, there should be some way that, or some experiment that could disprove it. And again, I have some sympathy with that perspective, at least in terms of if you're putting out a hypothesis of any sort, there should at least be a way of comparing that to an alternative hypothesis and seeing whether one has more or less evidence. On the other hand, I think that also comes back to the question we spoke about at the beginning of, does it explain everything about brain and behavior? And I think the answer is with the appropriate generative model. So in that sense, the free energy principle is not really a theory in and of itself. It's not a hypothesis for how things behave necessarily. That hypothesis only really comes in when you put your generative model in place as well. And the analogy I might use is that it would be extremely difficult to disprove the principle of evolution by natural selection, because it's tautologically true that those things that survive the best will end up surviving the best and will end up replicating. You know, those things that have a greater propensity or a greater fitness to then replicate will be more represented in the next generation. So it's very difficult to come up with an experiment that could disprove that, because it is just true a priori, essentially. However, you could put forward different hypotheses about different evolutionary trajectories and the sequence of events that happen and how different species are related. And I think the same, and you could test those hypotheses and you could falsify or at least provide evidence against one or other of those different views. And I think the same thing is true really with the free energy principle, that disproving the idea that we're minimizing surprise, well, it's almost nonsensical to try and do that.
Mm-hmm.
What to do is just say, well, let's formulate a view of what our internal model might be in performing this task, or performing this cognitive operation, or performing this movement, and formulate an alternative, and then compare the two and say, well, what predicts, or which of these predicts the data that I could observe the best, and provides more or less evidence for it.
Now, I would say that something that I was dealing with as I was trying to learn about this was, how is it applicable in day-to-day life? I think a lot of our listeners might be wondering, okay, well, this is theoretical, it's for the high-level neuroscientists, but give us a little bit of real-world applicability. Is this something that can be applied to daily life?
It's a tricky question, and I suppose it depends a little bit on what people want from it in terms of their daily life. I think it's quite useful in providing a perspective on our experiences in day-to-day life. I think the recognition that we're not directly observing what's out there in the world, and actually what we're seeing is an inference, or what we're experiencing is an inference of the world, is whether it's useful is, I suppose, a difficult question, but whether it's interesting, I find it is. thinking about how we go about making our decisions and that deciding between alternative hypotheses, working out what we can do in order to learn the most about the world around us. I think that's often quite a helpful thing. I mean, certainly something that's very helpful in sort of day-to-day clinical practice, where you're saying, well, which investigation should I be organising here? And you're essentially formulating it in terms of, well, given the results I'd get, what would I learn from that? And would that then advance what I want to do next? So I think it's quite useful just in terms of how we think about our interactions with the world around us, and at least for me is an interesting way of approaching that.
The other thing I saw that it may have a direct correlation is how we understand, diagnose, and treat mental disorders. What's your thought or experience with that?
Well, here I think this is something where I'd come back again to this idea of optimal inference with suboptimal models. So the idea that we might have different sorts of, or different people have different sets of beliefs that they use to explain the world around you. And so, you know, we spoke about the idea that a shadow being cast on the ground is a sort of two-dimensional image of a three-dimensional system, and there are an infinite number of ways you could create that same image. The only way you can really pick apart those different ways of interpreting it are by having different prior beliefs, different thoughts about what's plausible in the world around us, to then interpret that that image that could in principle have been generated in lots of different ways. And I think the same thing becomes very salient when we think about psychiatric, neurological disorders of brain and mind in different ways, because it tells us to stop thinking of it necessarily as a disorder and think of what would have to be the beliefs I would have to have for these behaviors, these inferences to seem optimal. So it sort of takes the perspective of the person who's having experiences that we might see as being suboptimal or abnormal. And it says, well, let's take it from their perspective and let's try and understand what set of beliefs they would have to have, what priors about the world would make everything they're doing appear optimal. Practically, you can actually infer those prior beliefs by using sort of simple behavioral tasks. So you can record the decisions people make. You can write down a model of how you think they've made those decisions, and then you can say, well, let's try putting in this set of beliefs and see if it behaves the way they did, or let's try putting in this set of beliefs and see if it behaves the way they did. Those beliefs, or the things that tend to be different between different people, tend to relate to something called precision. So that's our confidence in different parts of those models. So that might be our confidence in how reliably the world evolves from one step to the next through time, or how changeable it is. Or it may be our confidence in the sensory data that's actually coming in, how much weight we put on that. And you can imagine that in situations where people hallucinate, it may be that they're sort of failing to use those sensory data to update their beliefs and are generating inferences based upon their prior beliefs that are not necessarily accurate. So being able to sort of pull those apart and understand how those confidences or those precisions change is I think quite important in characterizing how people end up arriving at these different inferences. Final thing I'll say on this is that those sorts of precision parameters, those confidence parameters, neurobiologically look very much like sort of gain control, like turning up or down the volume of different pathways in the brain. And those are exactly the same sort of things that that physiologically are mediated by neurotransmitter systems. So things like noradrenaline and acetylcholine, and many of the things that are modulated by, or serotonin, many of the things that are modulated by the medications that are given in conditions like depression or schizophrenia or Parkinson's disease even, and many of these sorts of things. So there's a direct link there between the neurobiology and the beliefs that the neurobiology is underwriting, essentially.
Now, you had made a comment before that I want to follow up on, but how does the free energy principle correlate with the development of artificial intelligence? Because when I was first reading about it, this is applicable to all living things. And then as I read more, it's not just for living things, but it's also applicable to artificial intelligence. Can you get into that a little bit?
Sure. I mean, I suppose the principle of trying to build models of intelligent biological systems is more or less the same as the principle of trying to build artificial intelligence systems in and of themselves. There are, of course, some differences because there are biological constraints that artificial systems don't necessarily need to abide by in different sort of computing architectures. But the idea that I need to be able to reliably predict my data and that the range of parameters that I can output and be correct at, and if I'm an artificial system, please my trainer, is very similar to that sort of homeostatic drive that I was talking about earlier. One of the sort of big advances in artificial intelligence recently, of course, has been in generative artificial intelligence, and many people will be familiar with the idea of things like ChatGPT and the subsequent variants of that, or the generation of sort of deepfake imagery and those sorts of devices. And I think it's particularly interesting to see that development in that being able to actually generate data is precisely that process of trying to predict the world around us, to have a generative model underneath how we behave and what we choose to do. I think that some of the next steps, though, that we don't yet have quite in the same way in artificial intelligence are the idea of part of my model relating to actually having a body and being able to move around and influence the world around me. So as effective as things like ChatGPT are at producing very realistic text and answers to prompts, it'll be really interesting to see how that develops, particularly in combination with things like robotics, to actually having a body whose integrity needs to be maintained, who has something akin to homeostatic regulation built into it.
I mean, that's a whole nother topic of conversation, talking about AI and the growth of that and where that's going to go. But where do you see the future of the free energy principle going? Meaning, it has yet to be a consensus, general, unifying theory, but what further work, in your opinion, needs to be done so that it becomes more of a consensus theory? So
the reason I'm pausing is I'm sort of thinking, should it become a consensus theory, or is a consensus theory even a good thing? And I think that there's a lot of argument in favor of it, because it's helpful to be able to talk in a common language to people, to be able to have the same premise that you then work from. But that obviously has to be balanced against the fact that having multiple different approaches in the field, I think, is also a good thing, and having people who disagree with approach is very healthy in terms of advancing the field. In terms of broadening its reach and applicability, I'd suggest that probably the main thing is going to be accessibility, of providing as many resources to open it up to people who don't necessarily have specific training in a lot of these areas, just so that more people can get to grips with it, apply it, use it. So I think that's probably going to be the main thing. It will also be interesting to see in sort of years to come whether there's more application of active inference in artificial systems, and whether there's success in that in the same way that there has been for many years with sort of deep neural networks or some reinforcement learning applications in industry. I would imagine that demonstration of use cases like that will not only increase the number of people who sort of engage with it as a field, but just provide useful proof of principles as to the utility of it.
Now, give us kind of your crystal ball view, just because it's been almost half an hour here and we got to wrap it up, and I know you're super busy, but give us your crystal ball view. You know, this was a major breakthrough in terms of neuroscience over the last decade to 2 decades. What's the next big breakthrough in neuroscience that you see coming in the next 5 or 10 years?
It's an incredibly difficult question.
That's why I saved it for last.
The simple answer is I don't know. There are lots of exciting directions coming up in all sorts of areas. I mean, you know, we seem to be potentially around the corner for disease-modifying treatments for dementias. There's lots of exciting work in terms of neural prosthesis and deep brain stimulation devices and the way they're starting to now interact with the surrounding electrophysiology. I think, you know, in my own field, I think probably one of the things that will be most interesting going forwards is sort of breaking down the distinction between models of electrophysiology and biophysics, and models of belief updating and the computations that the brain is doing. I think we've come a long way towards breaking down that sort of Cartesian duality about separating those two things and finding a way of actually dealing with both together and using exactly the same dynamics to describe both belief updating and neural dynamics. So for me, that I think will be the exciting thing moving forwards.
I mean, I feel like we know so little about the brain that the advancements in neuroscience are so groundbreaking. And, you know, again, thanks for all that you and your group work on. Just in reading about the free energy principle, again, it's very complicated and I spent a lot of time reading about it, but the general consensus that I got, I think most people need to understand that we are all experiencing the world in different ways. And the way we interpret the world, your brain is taking in data and then interpreting it, and then you then analyze that. And so as a principle, it kind of guides the way that all living things or even non-living things make decisions, and how we guide our lives is basically through this principle. So truly fascinating. Thanks again for all the work that you and your group do. Look forward to seeing more breakthroughs.
Thank you very much. Thank you for having me.
All right, Thomas, have a great day.